5.
Hey, teacher. The marks in an English test in the school are normally distributed with a mean, mu, and a variance. 10% of the pupils in that school score more than 75 marks, and 25 of the pupils score less than 40 marks. Find the value of mu and variance.
Okay, right. So now there is a test or an exam, right? Test, okay. And the marks is distributed with the mean, mu, and the variance sigma square. Okay. We don't know what is the value of the mean and the variance or the standard deviation. We don't know, right? So the distribution is like this. Okay, x is distributed normally with mean equals to mu, variance equal to sigma square, right? So the first marks that is the first one that is given, 10% of the pupils score 75. It means that the probability of getting more than 75 is 0.1. Okay, so the probability of more than 75, this one, the probability of the marks more than 75 is 0.1. More than 75, 0.1. And as we know, we cannot find the probability of x. So you have to convert the x to z distribution, the standard normal distribution. How to convert? We use the formula, right? X becomes z. 75, you want to change to the z score, it becomes 75 minus mu divided by sigma. Both the mu and sigma, they are unknown. We don't know. Right? Now the next one will be we try to find 0.1. What is the z score? It means like this. It means like this. The z score is here is 0.1. Now I have drawn here the A to be positive. Can the A be negative? Cannot. Because if the A is negative, if the A is over this side, the A is negative, then the probability will be more than 0.5. Now the given probability is only 0.1. So 0.1, it should be positive A. The area should be smaller. If the A is a negative value, that means this area is also included, then the area will be more than 0.5. So it's not a negative A, it's a positive A. Right? So with the probability equals to 0.1, with the probability equals to 0.1, I try to find out what is the Z score, which I call it A lah. And I know the value of A must be positive. Next part. So how to get this A 1.281? Okay, so we look at the table. Look at the table. 0.1, probability 0.1. So I try to look for 0.1. Yes, it is between here. 0.1 is between 0.1003 and 0.0985 is between here. So since I identify the center, I must take the number on the left hand side. So it's 1003, extra 3. So I look behind, 3 is between 2 and 4. I can either choose 2 or I can choose 4. Either one will be the same. So if you give the answer, the difference of the last decimal place, difference of 1 or 2, it doesn't matter, right? Because the table we are limited by the accuracy of the table. The table is such that then we just copy the answer. Right, so answer will be 1.1.28. This is 8, 1.281 or 1.282. So 1.281 or 1.282, right? So I choose 1.281. Okay, never mind. So using this z-score here of positive 1.2, I equate with the z-score from the conversion. So I equate these two, right? When I equate these two, I bring the sigma over to the other side. I form one equation. This equation involves mu and sigma, both unknown. Okay, never mind, you just keep the mu and sigma there first. You just keep it as equation 1. So we try to look for the second equation. To form the second equation, they must give us something. So I read the question here. What is given? 25% of the student score less than 40 marks. You have to note that now it is less than 40. Less than, okay? Right. So it means that the probability of less than 40 is 0.25. So the probability of x less than 40 is 0.25. Okay, if you look at the diagram here, less than a certain number, you convert to z first. Convert to z first. The probability of z less than 40 minus mu over sigma is equals to 0.25. Now this is my z value. Okay, this is my z value, the z score. So this z score less than this z score is 0.25. So this situation is illustrated at the diagram below. So this is my z score, k, and less than k is 0.25. Then you may ask me, hey, how come you know the k is there? Oh, because they say less than. So I shade it on the left hand side, less than k. Less than k is 0.25. But can the value of k be positive? Can the value of k be over here? Can the value of k be over here? Positive number. The answer is no. Why? Because if k is a positive number and you get less than k, the probability will be more than 0.5. If k is a positive number, and the probability of less than k will be very big, it will be more than 0.5. You include the center line here, it will be more than 0.5. So it cannot be k positive, k must be negative. Okay, so now we are going to look at the table for probability 0.25. We are going to look at the table for probability 0.25 and see what is the z-score. After you have found the z-score, you must bear in mind that z-score is a negative number. Okay, so try to look for the z-score. So by using symmetry, the probability of z greater than 40 minus mu sigma divided by sigma is 0.25. Actually, it's negative of this number. What I'm trying to say is that by using symmetry, right, if you have a negative k here, so when you use symmetry, right, you change it to a positive k, and this value here is 0.0.25. That is what I'm trying to say. What I'm trying to say is that if the probability less than negative k is 0.25, then the probability greater than negative k is also 0.25. Greater than positive k is also 0.25. But this number is actually not k, it's negative k, right? It's negative k. Okay, right. Next, I'm going to look at the table for this number 0.25. 0.25. 0.25. Okay, I make a dot there first. 0.25. It's here. So 0.25 is between two numbers. The two numbers, they are 2514 and 2483. I choose the number on the left, 2514. 2514, I have extra 14. So I look behind, the nearest number is 13. Cannot be 16. Because 14, 16 is two numbers away. 14, 13 is only one number. So the nearest one is 13. And the number is, corresponding number is 4. So I try to read 0.674. 0.674. Okay, remember 0.674. So coming back here, this z-score here will be 0.674. Okay, the z-score will be 0.674. Now 0.674 is the symmetry value, the positive k. The actual question is this one. So it's actually a negative k. So when I get the number from the table, I have to add the negative sign myself. Cannot leave it as a positive number. So I add the negative sign myself. So now I try to form the equation. The z-score here, this z-score, I equate with the z-score from the conversion. So the z-score, I equate with the z-score from the conversion. So I try to form an equation. Yes, the equation is 40 minus mu equals to negative 0.674 sigma. So I have two equations here, right? I have two equations here, equation 1 and equation 2. I try to solve the two equations. Okay, so I use equation 1 minus equation 2. 75 minus 40. So 75 minus 40 is 35. Then negative mu minus negative mu. So it becomes negative mu plus mu. So the mu will cancel away. Over here, 1.281 sigma minus negative 0.674 sigma. Minus minus become plus. So I add 1.2810674. So altogether 1.955 sigma. Solving the equation, I have sigma equals to 17.9. So 17.9, I substitute back into equation 1. Substitute back here, 17.9. We'll get 17.9. So solving this equation, you will get the value of mu to be 52.07. Okay, so that's how we solve problems involving normal distribution, right?